Hello, just want to upload another video of a leak code problem that I found I was doing today. This one involves trees again, and this one is uh problem 1897, increasing order binary search tree where we have to turn a tree, um, uh, find the smallest node and just turn the tree into like this. Where all nodes will be the right of the next um, node, so on and so forth until the end. Um, so yeah, here is the class structure for a tree node that LeetCode provides. Um, Here is the tree class that I've been using for I think the last video as well, the last couple of videos of the trees. Same stuff. Um, Names might be a little bit different, but same idea. Here's this print tree. Still don't know how to do it. ChatGPT gave it to me. Um, but it works and it works, so I'm not questioning it. Print or in order, and there might be a couple of methods that I haven't included in here, that really aren't too important, um, for this problem. And in the public, uh, set in root to null when we create a tree variable down here. Um, Public methods for adding node. We just have to pass the variable. We don't have to pass the full node. Um, Print tree, which prints the tree, of course. Print in order, which prints in order from 1, 2, 3 consecutive. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. And then a get root that we will need for later. So um, my idea, the way I wanted to start for this was to create a whole new node, new root, so we can hold the smallest uh number in as that root, and move on from there. So we're going to declare tree node and new root. It's going to be a pointer. Tree node um current, which will also be a pointer. I didn't spell that right. Um, we'll leave these two alone for now. Um, in this, we're gonna have a helper method um, to help us traverse the tree and set it in order on the right side. So um, in this one, we're just gonna say new root is equal to null, just ptr current is equal to null pointer as well. Let's just leave it like that for now. And in this um, helper method is going to be a type void, and I'm gonna just call it in order. Um, it it has the same principle as this in order, where we recursively call on the left side until we reach um, no more left sides, and then we print um, whatever that value is. So in this one here, if a node is equal to null, we return back to whatever that the last node was, and then we print it. So here we would start off with the root node, move all the way left of that root node. We reach here, null, we would return back to zero, print zero. Then we would check um, the right side, then check all the left sides of that right side. Since there's nothing here, print this one, then check all the right sides of that right side. There's nothing there. Um, Print one, and then backtrack. Boom, boom, back to this one, this node. Check the right side since we already checked the left side of this node. Check the left side, so on and so forth, right? So same ideas for here, same idea. So we're gonna say tree node. We're gonna pass in a tree node pointer of node. Just call it node. You can call it root, whatever you want. I'm gonna just call it node for now. And in here, same idea. If node is equal to null, uh, we return. Then we recursively call in order on the left side. Boom. So what this does, it goes all the way to the left side. And what we want to do first is check if our new root is empty or not. So we know when to put a new root or when to add it to the right side of that new root. So here I'm gonna just say new root or new I'm gonna say new tree. Sorry, new tree. And the new root for this new tree is currently null. I'm gonna just leave it as n for null. Um, so in here, we're going to have an if statement um, that will check if the new root is null, so if it's empty or not. So we say if new root is equal to null pointer, new root is equal to a new instance of tree node. And then for this new instance, we're going to pass in the current nodes from the old trees, the current nodes value. Boom. Just like that. And then we're going to say current is equal to new root. So current is going to be doing most of the work for the new root to add um, the new nodes if the new root is already full. After this, we're going to say else. So if this is not true, else we say um, current right is equal to new tree node current nodes value. Same thing as this right here. So we're just setting the right side of um our current in our new tree. We're setting the right side to whatever the next variable is. And then we move current is equal to current right. So just move to the next right position for current. And then after this, we're going to say order in order call on the node right. So I'm going to explain what exactly is happening here right now. Let me just format this. Okay. So what's happening here is for this part, this is the helper method that's going to be doing all the work, right? So we're going to be passing in um a a node or a root and we're going to be traversing the old tree and then setting it into the new tree. So what we do is here is we would pass in the root of our old tree. So in this case, 10. Check if 10 is null, 10 is not null. We would traverse left until we reach a null. So traverse the left of 10, go to 2, traverse the left of 2, go to 0, traverse the left of 0. We reach a null. If we reach null, we return back to whatever this value is. Now we break out of here and we enter this section, this if statement. We say if new root is equal to null. In this case, it's our first time iterating through it, so it will be null. We say new root is equal to a new instance, tree node instance with the current node's value. So we create new root to be 0 essentially, right? And then current is also equal to new root. Yeah. Now, we would check uh now we return, since we already checked this, we can now check the right side recursively of this current node. Check the right side. Once we check the right side, we come back to this part right here and check the left side of this current right node. Since it's left, since we check left, it's null. We return to here, return back to 1. Then we enter, we check the if statement again. Is root node the new root null? No. We enter this part, the else statement. So current right now is 0 as well. Current is current right is equal to a new tree node instance of current node's value, which is 1. Boom. You put in 1 right there. Now we check the right side of 1. There's nothing here. Return. Since we already checked it, we can return back to 0. Since we already checked 0, we can return back to 2. We've already checked all the left sides of 2. Now we can enter 2 um uh to the right side of uh 1. Now we can check recursively check the right side of 2. So now we're in this part right here. So we check the right side of 2, which is 6. Now we already checked the right side. We come back to here. Check the left side of 6, which is 3. Check the left side of 3. Left side is null. Sorry, it's a bit tight right here, but left side is null. Since it's null, we return back to whatever this node is, which is 3. Then we can input 3 right here. We're in this part right here, right? Now since we've checked 3, we can check in order of node dot right. So whatever this current right, we check 3 is right. Now we're in 5. Now we go back to here, check node left. So we're checking 5's left. 5 left is 4. Now we check 4's left. 4's left is null. We return back to whatever this node is, which is 4. Enter this else statement. Create a new instance. So make 3's right equal to 4. Point to 4. Since we already checked 4, now we check 4's right. There's nothing here. We return back to here. We already checked it, so we can return back to here. Now we can put in 5. 5 doesn't have any right variables, so we would still check the right side. Since it's null, we don't have to put anything. Return back to 5. We already checked 3. Return back to 3. We already checked 3. Return back to 6. We've already checked all the left sides of 6. We can now input 6 right here. Let me make this a little bit bigger. I want to just show y'all how it is. Now we can check all the right side of 6. Boom, we're on 9. Now we check with this part, node 9's left. Node 9's left is 7. Check node 7's left. There's nothing here. Null. Sorry, this is empty, so this is null. We return back to 7. Now we can input 7 into here. Boom, 7. Let me fix that. That's ugly. 7. Since we were check 7, now we can check the right side of 7, which is 8. Now we check the left side of 8, nothing there. We can put 8 in here. Check the right side of 8, nothing there. We don't have to put anything. Since we rechecked 8, we can backtrack to 7. We recheck 7, we backtrack to 9. Now we check all of 9's right side. There's nothing there. It's null. Then we backtrack back to 9. Now we are able to put in 9. Oh, that's an ugly 9. 9. Oh, that's still an ugly 9. 9. There we go. Since we already put in 9, we can backtrack to 6. We already put in 6, we can backtrack to 2. We already put in 2, we backtrack to 10. Input 10. We check 10's right. There's nothing there. We backtrack to 10. We already been put it in. So that is it. Now all of our variables are here on all of our nodes are pointing to the right. Boom, 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 like that. So if you don't believe me, I will show you. Let me just run this real quick. Sorry, it doesn't like that I'm not using this. So here is our, oh man, what's going on? Oh, sorry. I totally forgot about this. Here, so that's essentially what this is doing. Now in the increasing BST, we would pass in a root of the old tree, and then we would just call in order on that root. So we're passing the old root into here, executing all of this, and then returning. Oh, sorry, I'm literally typing return new root. Since new root is now holding all of this, we can just return new root. So let me just run this real quick to show you guys. And again, sorry. Here we go is the original tree, as you can see, same thing. Um, what we do here now is we want to create a new um, root. So, and I've already added the nodes right here, so we don't have to like do all that work. So new root is equal to uh-oh, let me do this. Solution dot um where is it? Increasing BST and then tree dot get root. Oh, not two. We don't want a zero. Boom. So now we're passing in the root of the original tree into solution. So which would be 10 since that's our first root. Um, that's our first node being passed into here, and then it's going to do all that work, right? Now we want to create a new tree instance. So tree new tree. Um, but before now to add all the variables into this new tree, we would say tree node current. This would be a pointer, sorry, is equal to new root, and then while new sorry, not new current is not equal null. New tree dot add node current val current is equal to current. I think I spelled that right. So what this is doing is we're just passing um all the values into this new tree. And we're just traversing the right side of our current um new root. We don't need to do left because there's nothing in the left. Um, Sweet. Uh-oh. Um, Now that we have that, we can say cout new tree, and then new tree dot print tree, and then hopefully this works. Let's see. Sweet. There we go. As you can see, they are all on the right side, just how I showed right here. Um, yeah, that's pretty much it for this code. Um, yeah, thank you for watching. I hope you all enjoy.